Hello everyone, welcome to this video. In this video, we will be solving engineering mathematics questions which were asked in GATE 2013 paper of Aerospace Engineering. As we can see in this slide, there were total 8 questions asked in this paper, out of which 4 questions were asked for 1 mark and the rest of the 4 questions were asked for 2 marks. So let's try to solve these questions one by one. Yeah, coming towards the first question. This question is from the vector calculus. Here, they are asking us to calculate the directional derivative of function in the direction of a vector a bar at point 1, 1. Okay, so let's try to solve this. F of x, y is equal to x square plus xy square divided by root 5. Okay, so whenever we are calculating the directional derivative, we first take a gradient of this. Okay, so we'll operate a del of f of x y is basically 1 upon root 5. We can take out 2x plus y square I plus 2xyj. Okay, so this is the gradient of this function, and directional derivative is nothing but del of f of x y, and they're asking in the direction of a bar, so it is a bar divided by mod of a bar. Okay, and we have to do this at point 1, 1. Okay, this is what they are asking. So a bar divided by mod of a bar here is nothing but the unit vector in the direction of a bar. So what is mod of a bar here? It is under root of 2 square, which is 4, plus minus 4 square, which is 16. So it is root 20. Or we can even write it as it is 4 multiplied by 5. So it is 2 root 5 also can be written. Now coming towards the directional derivative part here. Here a bar is given, and now we will directly multiply it with this. So 1 upon root 5 is outside the bracket, and we are also dividing by mod of a bar. So that is 1 upon 2 root 5. And now we are just taking a dot product of it. So it will look like 2x plus y square into 2. So 2 into 2x plus y square, but at point 1, 1, it will be 1. It will be 2 times 2 plus 1 minus 2xy means 2 into 4. That 4 is negative minus, that's why I have considered here minus. So 2 times 4. Okay. So what we'll get here, root 5 multiplied by root 5 is 5. Multiply by 2 is 10. So 1 upon 10 in the denominator. 2 plus 1 is 3. 3 multiplied by 2 is 6. 6 minus 8 is minus 2. So the final answer is minus 2 by 10, which is equal to minus 1 by 5. So answer D is correct in this case. Coming towards next question. This question is from the calculus topic, integral calculus, where they are asking us to solve a definite integral question. Okay. So in this case, if we look into the denominator, which is x square plus 4x minus 21, it can be written as x square plus 4x plus 4 minus 4 minus 21. So it means it is x square plus 4x plus 4 minus 25. I will directly write. And what does it mean? It means it is x plus 2 whole square minus 5 square. And a square plus b square can also be written as a plus b, a minus b. So it is x plus 7 and x minus 3. Okay. So the given integration problem 4 to 5 x plus 2. Let's try to first calculate the partial fractions and then we'll put it into the integral form. So x plus 2 divided by x plus 7 and x minus 3 can be written as a divided by x plus 7 plus b divided by x minus 3, which means x plus 2 is equal to x minus 3 times a plus x plus 7 times b. Okay, so denominator will get cancelled, so I will not write it. In this case, if you put x is equal to 3, what will happen? The first term will become 0. And the second term is in the form of b, which will not become 0. So it will be 3 plus 7, which is 10. 10b is equal to 5. So b is equal to 1 by 2. Similarly, if you put x is equal to minus 7, this term will become 0. And we'll get minus 10a is equal to minus 5. Hence a is equal to again 1 by 2. So after putting into this given integration, now we can write it as integration 4 to 5. A is 1 by 2 divided by x plus 7 plus b again, which is 1 by 2 divided by x minus 3. Integration of 1 upon x is log of x. So considering that, we can write it as 1 by 2 ln of x plus 7 plus 1 by 2 ln of x minus 3. Okay. And here the limit is 4 to 5. Okay. So we'll try to solve this. Once we put 5 here, we'll get 1 by 2 ln of 12 plus 1 by 2 ln of 2 minus 1 by 2 ln of 11 minus 1 by 2 ln of 1, which is 0. So we'll not write it. So here it is ln of root 12 minus ln of root 2. It is plus, sorry. And the last term is a minus ln of root 11. So we can write it as ln of under root 12 multiplied by under root 2 divided by under root 11. So it means it is ln of root 24 by 11. So in this case, option A is correct. Okay. So it is just the partial fraction, and later we are integrating this partial fraction separately and putting the limits. Coming towards next question. This question is again from the calculus topic. They have given a function y is equal to mod of x. So it's a mod function, and at x is equal to 0, we have to check whether this given function is continuous or not, differentiable or not. Okay, so basic rule we have for the mod function is mod functions are always continuous. So if you look into this current example, mod of x will look something like this. Okay, so this function is continuous. It's not means at every point it is having a value, and at x is equal to 0, the value is 0. After that, as you increasing the value of x, the y is increasing, and below that, as you decrease the value of x, as it is a mod function, will end up with a positive value of answer. But At this point, x is equal to 0. We can clearly see there is a sharp edge. And at that point, we can draw infinite number of tangents to this. Okay, so whenever this kind of sharp corners are there, at that point the function is not differentiable. Why? Because it will not have unique slope. Okay, so a general rule which we can apply here is that mod functions is continuous everywhere, but it is not differentiable at a point where the function itself becomes 0. Okay, so y is equal to mod of x will become 0 at x is equal to 0. Hence, this function is not differentiable at x is equal to 0. So we'll write a statement, and with that statement, we'll be able to answer any of question which is in terms of mod. Okay, mod functions are continuous and mod functions are also differentiable everywhere except at point where function becomes 0. Okay, so mod functions are continuous everywhere, and mod functions are differentiable everywhere except at point where it becomes 0. And this question is about x is equal to 0, where this function is becoming 0. Hence, it is a continuous but not differentiable. Hence, option A is correct in this case. Coming towards next question, this question is from linear algebra. Here they are asking us one of the eigenvalue of a matrix A. One of the eigenvector of matrix A is 1, 1, 1. Then the corresponding eigen value is, they have given the eigenvector and asking us to calculate the eigenvalue. We know that A times the eigenvector, A means the matrix here, is equal to lambda times x. So using this logic, we will be able to calculate the value of lambda, which is eigenvalue corresponding to this eigenvector 1, 1, 1. So it will look like this: 1, minus 1, 0, 0, 1, minus 1, minus 1, 0, 1. The eigenvector is 1, 1, 1. Multiplication of this would be 1, minus 1, 0, plus 0. Then this is 0 plus 1 minus 1, minus 1 plus 0 plus 1. After solving this, we'll get 0, 0, 0. It means you have to multiply with 0 to this eigenvector. Then only it's possible that we'll get 0, 0, 0. Hence, we can clearly say the corresponding eigenvalue for the eigenvector 1, 1, 1 is 0. Okay. Coming towards the next question. This question is from, again, the vector calculus. Here they have given the surface integral I. Okay, I is double integration or surface integration in the form of f bar dot n bar ds. Okay, where s is the surface of the sphere of a unit radius at origin, and here I, j, k are the corresponding orthogonal vectors. Then they are asking us to calculate the value of I. So we can clearly see this xi plus yj plus zk is a unit normal to the surface, and the first function is a f bar. Here we can apply Gauss divergence theorem. Using Gauss divergence theorem, we can convert a surface integral into the volumetric integral. So this current integral can be written as integration over a volume V. So it's a triple integral, but we can write it as integration over a volume V. Divergence of F bar, okay, divergence of F bar into dV. So F bar is already given, y square z plus z square x plus x square y. And divergence of this F bar is dou by dou x of y square z plus dou by dou y of z square x plus dou by dou z of x square y. So the first term don't contain x, so its derivative is 0. Similarly, the derivative is 0 for second and third term. So ultimately divergence is 0. As divergence is 0, integration of divergence is also 0. So we can say that the value of I in this case is 0. So that is the answer. Coming towards the next question. This question is from Laplace transform, where shifting rule is given. Given that Laplace transform of e to the power at is equal to 1 upon s minus a, and they are asking us to calculate Laplace transform of 3 e to the power 5t sine of 5t. Okay, so let's try to solve this. First of all, we'll take 3 common, which is a constant term, and Laplace transform of e to the power 5t sine of hyperbolic of 5t. Okay, hyperbolic of 5t. So Laplace transform of sine of hyperbolic of 5t is 5 divided by s square minus 5 square, which is 25. So whenever we are using shifting theorem, that is Laplace transform of e to the power at into f of t is equal to f bar of s minus a. So using this shifting theorem, we can say this is equal to 3 times 5 divided by s should be replaced with s minus 5, s minus 5 whole square minus 25. So numerator is 15, denominator is s square minus 10 s plus 25 minus 25. Plus 25 minus 25 will get cancelled. So we'll end up with 15 divided by s square minus 10. Looking into the option, we can clearly say option B is correct in this case. Okay. Coming towards the next question. This question is from the linear algebra, where a matrix Q is given and they are asking us the values of A, B, C such that the given matrix is orthogonal. Okay. So when we say the matrix is orthogonal, whenever it satisfies the relation A into A transpose equal to Y, or A transpose is equal to A inverse. Okay. We can consider any of this. So let's consider this A into A transpose equal to I condition and try to calculate the value of A, B, C. So in this question, the matrix is given in terms of Q. So it's Q into Q transpose equal to I. So Q here is 1 by root 3, 1 by root 3. And 1 by root 3, 1 by root 2, 0, minus 1 by root 2, A, B, C, A transpose 1 by root 3, 1 by root 3, 1 by root 3, 0 C, B, okay, B will come here, 1 by root 2. So this, yeah, this is minus 1 by root 2 and A. Yeah. So if we take a multiplication of this first term has to be 1, 0, 0, 0, 1, 0, 0, 0, 1. And but if we try to write it in the mathematical way, it will look like, so this first row, this first element would be the multiplication of this row and this column. Okay, so it is 1 by 3 root 3 into 1 by root 3, which is let me try to draw it a dotted line. Yep. So it's 1 by root 3 into 1 by root 3 is 1 by 3. Similarly, plus 1 by 2 plus a square. The middle term would be similarly 1 by 3 plus 0 plus b square. This multiply by this 1 by 3 plus 0 plus b square, and the last term would be 3 cross 3 term would be 1 by 3 plus 1 by 2 plus c square. So if you look into this options, first is this has to be equal to 1, this also has to be equal to 1, and this also has to be equal to 1. So it is 1 by 3 plus 1 by 2 plus a square equal to 0. This is the first equation. So a square, sorry, equal to 1. So it is 2 plus 3 is 5 by 2, 5 by 6 plus a square equal to 1. So a square is equal to 1 minus 5 by 6, which is 1 by 6. Hence, a is equal to under root of 1 by 6. It could be plus or minus. In the same way, the second equation would be 1 by 3 plus b square is equal to 1. So b square is equal to 1 minus 1 by 3. It is 2 by 3. So b would be equal to root plus or minus under root of 2 by 3. So if you multiply with the root 2 and divide with the root 2, you will end up with plus or minus 2 divided by root 6. And the last equation is again same as first equation. So we'll end up with c is equal to plus or minus under root 1 upon 6. So looking into the options, we can say in this case actually both option B and D are correct. Both option B as well as D satisfies the condition. And even if we can cross check it by putting the values into the queue and try to check whether A and A transpose is same, or the determinant also we can calculate, it should be either 1 or minus 1. So in this case, both are satisfying the criteria. So option B as well as option D is correct. Coming towards the next question. This question is from the differential equation. The function y of t satisfies the differential equation d2y by dt square minus 2dy by dt plus y equal to 0 and is subjected to the initial condition y of 0 is 0 and y dash of 0 is 1. And they are asking us to calculate the value of y of 1. So let's try to solve this. The equation can be written as d square minus 2d plus 1 times y equal to 0 in a simplified form. And looking into this equation, we can clearly say it's a homogeneous differential equation. And for homogeneous differential equation, only complementary function is the solution. So we have to treat this d equation of f of d as algebraic equation and solve for the value of d. So it is d minus 1 whole square equal to 0. So d is equal to 1 comma 1. Here we are getting real and repeated roots. So the CF or the solution itself will be the CF in this case. Or we can say CF itself will be the solution in this case, which is equal to C1 e to the power t plus C2, or let's say x C2 e to the power t. I think, yeah. And now let's try to put the given condition. At t is equal to 0, y is equal to 0. So 0 equal to C1 plus, let's call it as a t here, C1 plus 0. We can say that C1 is equal to 0. So let's forget about this term. So now our equation would be y is equal to C2 e to the power t. Differentiate it, dy by dt is equal to C2 e to the power t. They have again given one condition. At t is equal to 0, dy by dt is equal to 1. So 1 is equal to C2 into 1. This implies C2 is equal to 1. So now our final equation is y is equal to e to the power t. And when t is equal to 1, we can say y is equal to e. So at t is equal to 1, y is equal to e to the power 1, which means e. Hence, option A is correct in this case. Okay, that's all we have from this 2013 paper. Thank you all for watching this video.